Hello viewer, welcome back to my channel. This is Dr. DORCAS NGIGI. We are moving on with the topic of uniform circular motion. Now we are in the fifth lesson. Okay. In the last lesson, we looked at I derived centripetal acceleration. And we looked at why we call it centripetal acceleration. We said when a body is going round a circular path, it accelerates. Okay? It accelerates. And we know that any time we talk about an acceleration, then there is a resultant force. Okay? From Newton's second law, when a resultant force F acts on a body of mass m, it generates an acceleration A. So when you talk about centripetal acceleration, it is because there is a resultant force, okay? And that resultant force, we're going to look at it today. We call that resultant force centripetal force. So centripetal acceleration due to centripetal force. So let's go back a bit and do a recap on what we looked at last time. So we said when a body is moving on a circular path, the magnitude of velocity, which we call speed, we said that magnitude of velocity, that is constant. And we said in our circle of radius r, if the magnitude of velocity, which is the speed of that velocity, is 2 meters per second, then the body will go round the circular path at constant speed of 2 meters per second. So the magnitude part of velocity, that one we said is constant. What we said changes is the direction. Okay? So from direction A to direction B. Okay? And we said when that happens, then there is that angle theta, meaning the first velocity at point A and the second velocity at point B, the angle between them, the two velocity, we call it theta, which we said is equal to the angle between the first radius from the center to point A and the other radius from the center to point B. The angle between the two radii, we said, is also theta. Why are the two angles theta? Because we said this VA is a normal to the first radius and VB is a normal to the second radius. Normal means is a line that cuts another one at right angles. So we said if that goes by theta, that also must go by theta. Where did that take us? It took us to, there is that velocity A and that velocity B. So because these directions are changing, this was direction A and this is direction B. So directions changing means velocity is also changing. So we said from velocity A to velocity B, then VB minus VA is delta V, change in velocity. So we said that is delta V, change in velocity. And then what is constant in that triangle is the speed. The speed is not changing, 2 meters per second. But velocity is changing, so we have delta V, change in velocity. Then constant speed S. In this triangle here, CAB, we have R as constant, so R is constant there. But what is changing is the arc length, delta S prime, delta S prime. So what did we say? We have two constants and an angle which is equal to the two constants and an angle. So we say this triangle, C prime OP, is similar to triangle CAB. Okay? And because they are similar, then we said then delta S over delta V equals to R divided by S. So we derived that. So we came down with that, making delta V the subject. Why delta V the subject and not the others? Because delta V divided by delta T gives us acceleration. So delta V made the subject, gave us delta S prime times S over R, where S is speed, delta S prime is change in arc length, divided by R, R is the radius. Now S and R are constant. delta V and delta S, those ones are changing. So we divided everything by delta T, divided by delta T, divided by delta T, but we know delta V over delta T is acceleration. So we said that acceleration, which is delta V over delta T, is therefore equal to delta S prime over delta T multiplied by S over R. So, but what is delta S prime over delta T? We said S prime is the arc length. So that one is length. The arc length is a length. So the arc length, a length divided by time, gives us speed. So we say delta S prime over delta T is the speed S. Now we have two speeds, this one and that one. So we say acceleration, so which is centripetal acceleration, equals to S squared over R. So V squared over R or S squared over R is the same thing, gave us the centripetal acceleration. So that is what we did in the last lesson. So in this lesson, I want us to look at an example where we can determine we can use that centripetal acceleration. Okay. So we have an example here. Say a point on the rim of a wheel has a velocity of 5.6 meters per second. To stop. If the rim has a radius of 0.4 meters, calculate A, the angular velocity of the point and B, the centripetal acceleration. Okay? So we have that. Now, going to our question, the body is going around a wheel. So we have a point. This point is going round the wheel, and it has a velocity with a speed of 5.6 meters per second, and the radius of 0.4 meters. Okay, that's our radius. So the question is the angular velocity of the point. Angular velocity, we said, is a velocity in terms of angles. Angular velocity. So we give it in radians per second. In radians per second. Let's go back. What is a radian? A radian is an angle subtended at the center of the circle by an arc length equal to the radius. A radian is an angle subtended at the center of a circular path by an arc length equal to the radius. So we say a length equal to the radius subtends a radian. But we are told it is moving around a circular path, of course, at constant speed, which we call velocity in our case, 5.6 meters in 1 second, per second. So the question is, if we cover a distance of 5.6 meters, how many radians will we have subtended at the center? So in 1 second, it is covering an arc length equal to 5.6 meters. So the question is, how many radians are those in 1 second? We said to calculate that, you simply take that velocity, which is linear velocity v, because it is in meters per second, divided by the radius of the circle. Why radius? Because each radius subtends 1 radian. Each radius subtends 1 radian. So to know how many radians are subtended by 5.6 meters, I must divide by 0.4 meters. Okay? When I do that, then I get the number of radians covered by my point in 1 second. So we do that. So V, which is 5.6 meters per second, divided by the radius, which is 0.4 meters. Okay? So each 0.4 meters subtends 1 radian. So how many radians are this? That goes, so becomes 56 per second over 4. So by 4, 1, by 4, 1, carry 1, 16, that is 4. So we get what? So this is omega, angular velocity, omega is given in radians per second. So we say omega equals to 14 radians per second. And so that is the first answer to the first point. That's 14 radians per second. Okay? How did we know that? Because an arc length equal to the radius subtends 1 radian. So the 5.6 meters are how many radians? Subtended by how many? An arc length of 5.6 meters. How many radians does that arc length subtend at the center? And since the 5.6 meters are in 1 second, then we'll have calculated the number of radians in 1 second, and that is our omega, angular velocity. Part B of that question, so this is A. So part B, we need to calculate the centripetal acceleration. Now centripetal acceleration A, we saw it as v squared over r. And I also said, remember always, even as we are talking about v squared over r, that v is not constant, so it should be s squared over r, where that s is the speed, okay? The linear speed. So is equals to what now? It is moving at 5.6 meters per second, so it will be 5.6 meters per second. I square that. Some water. Divided by r. R is 0.4 meters. Okay. So what do we have there? So I have 5.6 times 5.6, that's 31.36 meters squared per second squared. I'm squaring everything in the bracket, divided by 0.4 meters. Of course, times 10 times 10, that becomes 313.6 meters per second squared. Now remember, this meter cancels with 1 meter, leaving us with 1 meter, and then per second squared divided by 4. So I cancel. So I get 10 by 4. So which is equals to 78.4 meters per second squared. That is the centripetal acceleration. So centripetal acceleration is 78.4 meters per second square. So that question, as you can see, is very easy to work out. We have already worked out the angular velocity omega, which we said is v over r. Now we understand why. Because anytime we take linear velocity, which is in meters per second, we divide by the radius, we'll get radians. Because each radius subtends 1 radian. So if we divide by the radius, the length in meters of the radius, then we are going to get the number of radians in 1 second. And that is omega. So about centripetal acceleration, we said is v squared over r, s squared over r. And so I just work out r is 0.4 meters in our case, 5.6 meters per second. I square that, then I get that. I just work out through, then I get 78.4 meters per second squared. Okay, so that brings us to the end of our lesson. Thank you so much for watching. Don't forget to like, subscribe, and share with those people you know require this knowledge. Until next lesson, goodbye.